Hey guys, today we're going to continue with implicit differentiation, and what we're going to focus on today is what's called the second derivative. And what it means to be the second derivative, that means we're going to take the derivative of the derivative. Right? And for some notation, so when we have been taking the derivative, we would do f prime to indicate the derivative, or we would do, and what we were doing last time, dy dx. Those stood for the first derivative. Second derivative will be notated with a double prime, or d2y over dx2. Those are the notations for the second derivative. Now, what we're going to be doing, and I've got a couple examples here to do this, what we're going to do is we're going to find the derivative like what we were doing on the last lesson. Okay. Then we're going to take the derivative of that answer. Anywhere we see a dy dx, we're going to replace it with what it equals. And we will also replace, if we see the original equation, and I'll kind of point out what I mean in this first example. With what it equals as well. Okay, so let's begin with number 1. Derivative of x squared is 2x plus the derivative of y is going to be 2y dy dx equals the derivative of 25 is 0. So now we're going to solve for dy dx, just like what we were doing on the last lesson. Okay, so that piece there, I didn't do a lot of talking because that is exactly what we were doing on the last lesson, whether it was yesterday or whenever you did that lesson. So now, because I'm asking you for the second derivative, we're going to take the derivative of this answer. Okay, well now, it's supposed to be an arrow and it doesn't look like one. But now I have a quotient rule, so I'm going to have to use my quotient rule to take the second derivative. So derivative of the first, keep the second, minus, keep the first. The derivative of y would be 1, but since it's y, I have to have dy dx over the second squared. Okay, so now I have negative y plus x dy dx over y squared. But do we know what dy dx equals? Yeah, it's right here. So I'm going to replace dy dx with what it equals. Now I have negative y plus x times negative x over y squared. Okay, if that's over 1, I multiply straight across. So I have negative y plus negative x squared over y squared. Well, now I gotta clean up this numerator. So I'm gonna put this over 1. I have to get a common denominator. Means I'm gonna multiply by y. Now I have negative y squared over y plus negative x squared over y squared. I bring my numerator together. I have negative y squared minus x squared over y squared. If I imagine this as a fraction, now I don't divide fractions. Instead, I multiply by the reciprocal. Which then gives me negative y squared minus x squared over y cubed. And yeah, you're probably thinking, oh good, we're done. There's nothing more I can do. However, there is. Look back at the original equation. The original equation was x squared plus y squared equals 25. My numerator right now is pretty close to that. So what can I take? If I take out a negative 1, I would have y squared plus x squared. And then, do I know what this equals? Yeah, it equals 25. So I'd have negative 1 times 25 over y cubed, or negative 25 over y cubed. Okay, number 2. Derivative of y squared, 2y dy dx. The derivative of x was 4. Let's solve for dy dx. Okay, so I get dy dx equals 2 over y. Second derivative. Actually, before I take the second derivative, would you guys, I hope you agree, that 2 over y would be the same thing as 2y to the negative first? The reason why I want to do that is because now I don't have to do a quotient rule when I take my second derivative. Okay, so I'm cheating the system just a little bit. So that's the answer to dy dx. Now I'm going to find my second derivative. So derivative of 2 to the negative, y to the negative first would be negative 2y to the negative third. Dy dx. Nope, negative second. Helps if I can count. Sorry. Take that exponent down, multiply, subtract 1. Okay, sorry. So now I'm going to replace dy dx with what I know it equals. Oops, let's undo that. Let's do that in a different color. Okay, so I would have negative 2y to the negative second times, what was dy? That was 2y to the negative first. Negative 2 times 2 is negative 4y to the negative third. Which then is negative 4 over y cubed. But now look, I know what y squared equals. Y cubed is a y squared times y. So negative 4 over y squared times y. I know that y squared equals 4x. And then look, my pretty 4's cancel. And I'm left with negative 1 over xy as my derivative.